In this video, we're going to look at Le Chatelier's principle. So sometimes we have a reaction at equilibrium, and we don't want the reaction to keep going back and forth in the forward and reverse reaction. In this case, we could add a stress to make the reaction move just in the forward direction or just in the reverse direction. So if we would like, we could favor the forward direction if we add a certain stress, or the reverse reaction. So what are we talking about when we say stress? A stress means I could change the temperature, the concentration, or the pressure on the system at equilibrium. So let's look at each of these individually. First, let's talk about concentration. When the concentration of any substance is added, we will always shift away from wherever the stress is being added. So here's an example. What I'd like you to do whenever you increase or decrease the concentration of something is first note what side of the arrow it's on. Are we talking about a reactant or a product? So let's say my stress is to add more ammonia. Ammonia NH3 is on the left-hand side of the arrow. So here's my arrow, right in the middle, this double arrow. It's at equilibrium. According to Le Chatelier, we could add a stress to make the reaction shift just to the right or just to the left. Here we're adding NH3. Here's the NH3. And it's on the left of the arrow. We're going to shift in the opposite direction, or away from the stress. Since NH3 is on the left, we will shift to the right. Okay, let's look at temperature. When we increase the temperature, we're going to favor the endothermic direction. We can still look at this the way that we have been, though, where you're going to shift in the direction or shift away from the stress. So our stress here is going to be more heat. So what you're going to do, when it says increase the temperature, you find wherever the heat term is written in the equation. Sometimes it's not going to say heat. Sometimes it's going to say like joules or calories. That's fine. Find what side of the arrow that's on. So our heat is actually on the right. It couldn't fit up here, but I'm just going to rewrite it over here. I think it'll be easier for you to see. So plus heat. If I increase the heat is on the right side of the arrow. I'm going to shift in the opposite direction, so I'm going to shift to the left. You always shift away. Now, we also said that this is favoring the endothermic direction, because when you're endothermic, heat is a reactant. If I need to make heat a reactant, well, if we're going left to right, heat's a product. That's not the endothermic direction. So if I went right to left, meaning the reverse direction, that would be favoring the endothermic reaction. Next, we want to look at increasing pressure. When you increase pressure, you're going to favor the side that has less moles of gas. We've talked about over and over, pressure only affects gases. So you've got to be really careful that you're looking at just gases. So here is a gas, here is gas, here is gas. If there were no gases in this equation, pressure would have no effect. So what we need to do is count how many moles of gas we have. We have 1 nitrogen here, and I have 3 hydrogens here, 3 moles of hydrogen here. So all together, on the left-hand side, I have 4 moles of gas. On the right-hand side, I have 2 moles of gas. Which side has less? The right. So when you increase the pressure, you shift to the side that has less moles of gas. The right side has less moles of gas, so I'm going to shift to the right. So if we mentioned that if there was no gases, the pressure would have no effect. Additionally, if the mole ratios were the same, pressure would also have no effect. So you want to be careful about that. Like if I had 2 moles on the left and 2 moles on the right, there would be no shift. The other thing you want to keep in mind is that pressure and volume are inverse. So they could phrase this question as increased pressure, meaning you go to the side with fewer moles, or they could say decreasing the volume, because decreasing the volume is the same thing as increasing the pressure. And the opposite also holds true. If increasing the pressure, you go to the side with fewer moles of gas, then when you decrease the pressure, you go to the side with more moles of gas. Last thing I want to talk about is a catalyst. We said catalyst increases the rate of the forward and reverse reaction, but it's not going to make you shift to the right or the left. It's just going to make the reaction happen faster. Okay, so let's give you another example. If you could take out a piece of paper and copy this down. I want to explain what's happening in terms of Le Chatelier's principle. So, here's a reaction at equilibrium. 2A gas plus 3B gas yields A2B3 gas plus heat. Let's just go through what would happen. Let's first look at concentration. If I increase the concentration of A is on the left of the arrow, I would shift to the right. When we shift to the right, that means that we're going to create more of everything that's on the right. I'm increasing A, causing more collisions between A and B, which is why the reaction shifts to the right. We're producing more product. As a result, when you shift to the right, everything on the right goes up, everything on the left goes down. So let's look at another example. If you were to increase the concentration of B again is on the left of the arrow. Since it's on the left of the arrow, we're going to shift to the right. When you shift to the right, it's saying make more of everything on the right. So A2B3 would go up. Because I shifted to the right, I used up my A and B, so the amount of A and B would go down. I'm going to just write a minus sign over time. Let's say you increased A2B3. A2B3 is on the right of the arrow. So since I'm on the right, I shift away from the stress. I would shift to the left. Whatever direction you shift, you make more of whatever is on that side of the arrow. So if I shift to the left, the amount of A and B will go up over time. Let's look at temperature. If I increase the temperature, well, here's my heat. I would shift in the opposite direction, which would be to the left. Whatever direction you shift, everything on that side goes up. So if I shift to the left, everything on the left goes up. Everything on the right goes down. The A2B3 got used up to make A and B. And one more thing, pressure. We said that when you increase the pressure, you shift to the side with fewer moles of gas. Let's just look, do we even have gas? Yes, gas is involved. The left side of the arrow has 5 moles of gas. The right side has 1 mole of gas. If you increase the pressure, we would shift to the right because there are less moles of gas. But then what happens as a result of shifting to the right? Well, we shift to the right, everything on the right goes up. So the amount of A2B3 will go up, everything on the left goes down. So it's not just about which direction you shift, we also need to know what happens as a result of the shift. Whatever direction you shift, everything on that side goes up, and everything on the side away from the direction you're shifting will go down because it's getting used up or colliding to make whatever it is you're trying to make. We'll discuss more examples in class tomorrow.